we eventually divide by the derivative, right? Because x squared, we would be dividing by 4, and we'd end up with a sine of x squared plus 10 in our problem, plus some u stuff. We have to think of, if we're going to choose this, we have to be able to get rid of the other x stuff, because our integral can only be in terms of u. So the 4x would not get rid of this stuff, but this would get rid of the 4x.
Intuition.
So that's only the second example. Why don't you try this one, see if you can figure out what your u should be. If we choose u as our tangent x, then du dx equals secant squared x. Solving for dx, that is du over secant squared x.
I got that.
Rewriting our integral, it's u secant squared x dx, which is du over secant squared x.
Okay, I got
They
that.
gone. So we have integral of u du until the end. I will, yeah.
You.
So antiderivative of u is 1/2 u squared.
Oh. How did you?
Oh. Oh.
Did you do that by changing it into? Yeah.
So do you see the value in u substitution when we end up with an integral of u? That's a whole lot better than that, right? So our objective is to rewrite the integral in terms that we know the antiderivative. So 1/2 u squared. So it's 1/2 tangent squared x, and we're going to evaluate it from 0 to pi, which is our dumb boundaries of integration, because tangent of pi is 0. Tangent of 0 is 0. We get 0 minus 0, which is 0. Isn't that fun?
I couldn't just use my calculator.
Watch what I do here.
No.
Now it's a completely different
Yep.
one.
Do a square root one. We want to do a square root one.
Okay,
No, we
so some students will look and they say, okay, u substitution, now I've got these numbers out here, nothing changes, you're just trying to find the antiderivative, then you evaluate the antiderivative as we normally do. I'm not going to finish that.
Wait, how did you get the integral of u du to 1/2 u squared? That.
Like the antiderivative of x is 1/2 x squared.
So once you get it into terms, once you put u back in, you have to take the antiderivative of that.
Right, that's
And
when you do
then
it.
fill in.
Don't, yeah, so a lot of people will go like this and like, oh, I know what u is, and I make it tangent, and then you're going the wrong way. You worked here to get this, now that's when you find the antiderivative. Okay?
Why do we keep on
You have
doing
an
one
11.
face?
just a
You have an 11.
Oh, boy.
You turn older when the minutes change.
That's, yep.
Alright, so evaluating the antiderivative or integral of cotangent of x.
But why do we keep on doing these? Like, are these the only kind of problems?
No, you just do a square root one. Square root one. Square roots.
So,
And I think let's choose X. Yeah.
Okay,
doing mainly.
Alright,
Mr. Winkler.
time for a challenge. 8.
What's our u?
X
X
cubed
X
plus
cubed
1.
X cubed plus 1, what's the derivative of x cubed plus 1?
I don't know.
3x.
It's a quadratic, so we're going to undo that x squared out front. So your
Make
u,
that 9 instead of 8.
Hold up. Yeah,
Hold
because
up.
then it would.
That'd be
yeah,
really
but I
nice.
can't change a 3 easily
Well,
to a 9.
No, you could just erase the lower left bout, and that becomes a
I
9.
can a calculator.
So are we
Seriously,
not
take
doing
problem.
anything with X one?
Then it's solved.
dx is du over 3x squared. So the x squared disappear. I get an 8/3.
Yes, you can.
Integral natural log of u du.
One over u. Times 1.
We don't know the antiderivative of natural log of u until 6.3. Is
Why'd
it?
you do this problem then?
No, isn't that one
Because
over
we want-
1 over u?
That's the derivative.
Oh, it's a derivative.
But I'm just gonna withhold him from
Okay, so can you take this example and carry it to other types of
Yes,
examples?
No,
that's what matters.
You can't?
I don't understand.
What part?
Well, once you get to this point, you should have an expression that you know the antiderivative. This one, you just don't know until you learn integration by parts. But that's U substitution. Here's another U substitution. We don't know what our U is here. Okay? We shouldn't choose U as X. That doesn't really get us anywhere.
Cotangent.
How could I rewrite cotangent?
1 over tangent.
1 over tangent. Or cosine over sine. Which one do you want to try?
Cosine over sine.
I agree. Cosine x over sine x dx. So now we have options for our u. We could either choose cosine x or sine x. And we know the derivative of them are the opposite, so it's going to undo something. So let's try cosine x, even though that's the wrong choice. So du dx equals negative sine x, dx equals du over negative sine x. So we get u over sine x
You don't need to do that.
du over negative sine x. Do you see that we chose the wrong thing?
Yes.
It didn't get rid of our x stuff. We have u's and x's. We did something wrong. Okay? So that is not the right choice for u. We're going to choose
You just know that.
the bottom, which is sine x. So it's the integral of cosine x over u. And dx is du over cosine x. Look at that. It's the antiderivative 1 over u du. What's that? For the antiderivative of 1 over u, it's natural log absolute value of u.
Can you explain why it's absolute value?
No. Natural log value of u
I'm wondering that for 2 days.
is sine x plus c.
Because you can't take the absolute, you can't do the natural log of a negative.
How do you know this?
Okay.
I tried typing in my calculator.
So I think in your assignment you'll have tangent. Remember, tangent is sine over cosine. So choose the bottom one. So in tangent you would choose cosine. For cotangent, choose sine. Choose the bottom one, you'll get the right answer. Okay, there's more to this section. We have to solve differential equations by separation of variables. I will not talk about that today. Stay tuned, we'll do it again tomorrow. Peace out.